Okay, day one of limits, we're going to look at limits graphically. The key to limits is if f of x is arbitrarily close to some L for all x sufficiently close to C, we write the limit of f of x as x approaches C equals L. So a limit, we talked about this last year, it does not have to be the exact y value. It's just what the y's are approaching as x approaches a certain value. So for this first example, A here, if we're doing f of 1, that is the exact y value when x is 1, which is 2. Limit of f of x as x approaches 1 is the y value as x approaches 1. So as I approach 1 from the left, so if I'm coming from the left moving right, or if I'm coming from the right moving left, either way my y's are approaching 2 as x approaches 1. So there the f of 1 and the limit of f of x as x approaches 1 happen to be the same. Now in the next one, f of 2 is the exact y value when x is 2, which is 5. The limit of f of x as x approaches 2. Well, as I approach 2 coming from the left, so right before I get to 2, if I'm at 1.99999, where are my y's approaching? They're approaching 3. Same thing as I come from the right. If I'm at 2.000001, where are my y's approaching? They're approaching 3. So the limit would be 3. For f of 3, that is the exact y value when x is 3, which there is none, right? There's no y value. So that we could say is undefined or does not exist. Undefined, does not exist. But the limit of f of x as x approaches 3, well, as I approach 3 from the left, so let's say I'm at 2.9999, I'm approaching 4, and same thing from the right. If I'm at 3.00001, my y's are still approaching 4. Right-handed limit, that's the limit of f of x as x approaches, let's say, some a value, and it looks like a plus sign up in the exponent. That means from the right. So I would say the limit of f of x as x approaches a from the right. And limit of f of x, this would be as x approaches a from the left. So that's read from the left. Note, limit of f of x as x approaches some c only exists if and only if the limit of f of x as x approaches c from the right equals the limit of f of x as x approaches c from the left. Okay, given the graph of g below, find each of the following limits if they exist. Okay, as we approach 2 coming from the left, so I'm coming from the left, I'm moving right, I'm getting closer and closer to 2, I'm at like 1.999. My y's are approaching 4. So that's the limit. Limit is what the y's are approaching. If I'm approaching 2 from the right, if I'm at 2.00001, my y's are approaching 1. That means the limit of f of x, of g of x as x approaches 2 does not exist, because the limit from the left and the limit from the right are not approaching the same value. Basically, there's a jump in the graph. As we approach 4 from the left, okay, if I'm at like 3.999, my y's are approaching 1. 4 from the right is approaching 1. That means the limit of g of x as x approaches 4 is 1. Limit from the left, limit from the right are equal. Therefore, limit exists, and it is that x or that y value. Next is want you to sketch a possible graph with the domain from -2 to 1. Okay, they say f of -2, f of 0, f of 1 all equal 0. That means -2, 0, 0, 0, and 1, 0 are all points. And then they say the limit of f of x as x approaches 2, or as it approaches -2 from the right is 2. Limit of f of x as x approaches 0 is 0. Limit of f of x as x approaches 1 from the left is 1. So I'm going to plot -2, 0. 0, 0, and 1, 0. We know they're those points. The limit as we approach -2 from the right is 2. So that means this graph is going up towards 2. That's going to have an open circle. Otherwise, this would not be a function because it would not pass the vertical line test because we have the closed circle at -2, 0. We know the limit of f of x as x approaches 0 is 0. So from the left, from the right, we have to be approaching 0. So that has to connect there. And then the limit of f of x as x approaches 1 from the left is 1. Okay, so then that is connecting there. So that's an example of what the graph could look like. Given the graph below, find each of the following. Okay, limit of f of x as x approaches -4 from the left. Okay, coming from the left, moving right, that would be 0. -4 from the right, tracing the graph from the right, we're going up to 1. That means the limit at -4 does not exist because from the left and from the right was not the same. F of -4 is the exact y value when x is -4. -2, okay, well, to tell the limit at -2, we would have to check -2 coming from the left, coming from the right. They're both approaching 0, so my answer is 0. F of -2 is also 0. What about the limit at 4? Well, we have to check from the left. We're approaching this y value. I don't know, I'll call that maybe about 2.6. From the right, same thing. So I'll say that's about 2.6. I'm just approximating. And that does happen to be the exact y value as well because it's continuous there. So places where it's continuous or there's holes, the limit exists and will be equivalent to the y value. If you see an asymptote at x equals c, the limit as x approaches c will be either it does not exist, infinity, or negative infinity. So if they're both going up to infinity, it could be infinity. So here, limit of f of x as x approaches c would be infinity. Limit of f of x as x approaches c for this one would be does not exist. Because from the left, we're going to negative infinity. From the right, we're going to positive infinity. So those are different. Sometimes people say that doesn't exist at either of these because of the fact they say infinity is not a value. It just depends. Different books do different things with that. Okay, so a from the left. From the left, we're going down to negative infinity. From the right, we're going up to positive infinity, which means at a, limit does not exist. F of a does not exist because there's no exact y value when x is a. Limit at 0. Well, let's see. As we approach 0 from the left, 0 from the right, what we're a little lower than negative 2, so I'll say maybe negative 2.3. F of 0. So the y value when x is 0, it's up at 1. So we're up here at 1. Limit as x approaches c. Well, let's see. From the left, from the right, we are not approaching the same value, which means limit does not exist. F of c, the exact y value when x is c is down here at negative 3. Okay, that's it for limits graphically.